Hello students, I am Dr. Varun Mohan from ABES Engineering College, Ghaziabad. This is the lecture 7 of the lecture series of Unit 3 of Engineering Chemistry, code BS 101 and BS 102. In the previous session, we discussed about various factors influencing the rate of corrosion, and we discussed about some corrosion issues related to some specific industries. Today, we are going to discuss a very important topic, that is the preventive measures of corrosion. These are the contents of today's lecture. First, we shall discuss about the protective measures against corrosion, which will include the discussion on the material selection and design, the modification of the environment, modification of the properties of the metal, application of protective coatings, and cathodic protection methods. After that, we shall answer a few questions which have appeared in previous year's examinations. So let us start with the protective measures against corrosion. Corrosion is an undesirable process. It causes the loss of money and it may also cause the loss of lives. So it has to be prevented. To prevent the corrosion, there are several methods which are listed here in the slide. One of them is the material selection and design. It means we can choose a proper kind of material to prepare the object, to prepare the structure, and we can design the structure in such a way that it can prevent corrosion. Further, we can modify the properties of the corroding environment and we can modify the properties of the metal itself. This will also help to prevent the corrosion. We know that the corrosion is a surface phenomena, so it starts from the surface of the metal. So if we apply some protective coatings on the surface of metal, then corrosion can be minimized. Furthermore, we can follow certain cathodic protection methods which can also prevent the corrosion. So we shall discuss these methods one by one. And first we shall discuss about the material selection and design. While preparing the structure, we can prevent galvanic corrosion by following certain sets of rules. So these rules are avoiding the joining different metals. It means that when we have to prepare the structure, we should try to prepare it with the single metal, because if we use two different metals, those metals may work as anode and cathode respectively. So one metal is working as anode, whereas the other metal is working as cathode, and the metal which is working as anode will undergo corrosion. So two different metals may form a galvanic couple, in which case one of the metal which is working as anode will undergo corrosion. To avoid it, we should use single kind of metal. Even if we have to use different kinds of metal, we should choose them in such a way that those metals should not have a large gap in their position in the galvanic series, because larger the gap, greater will be the rate of corrosion. Higher rate of corrosion. Even if we have to use the metals which are having a significant gap in their position in the galvanic series, then those should be separated with the use of an efficient insulator, and we can use a plastic washer for this purpose here. Further, if we are using two metals, then the metal which is anodic and the metal which is cathodic, those should not differ much in their area, because we know that the rate of corrosion is directly proportional to the cathodic area and inversely proportional to the anodic area. It means larger the area of cathode and smaller the area of anode, higher will be the rate of corrosion. So to avoid corrosion, the anode and cathode should have almost similar area. Further, the bolts, nuts, and screws are those parts which are having lesser area in a structure. So these parts should be made up of noble metal. If those parts are made up of anodic metal, in that case, the anode will have lesser area and rate of corrosion will be high. So these parts should be made up of only the noble metal. Further, proper insulation should be ensured wherever possible because it will help the structure to prevent from the stray current, to prevent the flow of stray current, or it will protect the structure from the stray current. So here, stray current will be avoided. We should also remember that continuous welds should be preferred as compared to the intermittent welds. So we should always use the continuous welds wherever possible. Now about the design of the structure. While designing the structure, we should also take care of certain rules so that the corrosion can be minimized. For example, L, T, and U kinds of structure should be avoided. These types of structure have larger number of angles, corners, and edges. So these are difficult to clean. Surface treatment is very difficult in such structures. So these structures should be avoided as far as possible. We should prepare the structure in such a way that it should not allow the moisture retention. For example, suppose we have this kind of structure. So here water droplets may rest. Water droplets. We can prepare the structure in an alternative way. So the shape here may be like this. Because of the curved surface here, the water droplets will automatically drain off. So our structure should not allow the moisture retention to prevent the corrosion. Further, it should ensure proper air circulation. If proper air circulation is there, in that case, it will dry completely and there will be enough access to the oxygen. So in that case, no area will be poorly oxygenated and differential aeration corrosion will not happen. For example, suppose we have a water tank which has this kind of structure. And this structure is resting here on the foundation. Now, it can be alternatively prepared as like this. Here, we may have plastic insulators. So these are the plastic insulator. plastic insulators, and it may rest on the stand here. So this is the stand. Similarly, these are the legs on which it will rest. So in that case, there is proper air circulation, and this proper circulation of air allows the oxygen to be accessible in all areas, and there will not be differential aeration corrosion. Further, the structure is designed in such a way that it allows the complete draining and it does not allow the moisture retention. So we should prefer this kind of structure. Then we should avoid sharp bends. Instead of sharp bends, we should have smooth bends. For example, suppose we have to prepare a structure having the shape like this. So these are the sharp bends which may cause crevice corrosion. So here crevice corrosion may occur. So we can alternatively we can design it as the structure having the smooth bends. So here we have sharp bends which causes crevice corrosion, but here we have smooth bends. It is having sharp bends and it is having the smooth bend. Then if the structure has anodic parts, these are the parts which will undergo corrosion. So those should be replaceable so that the whole structure is not damaged. Wherever possible, the structure should have insulation so that it is protected from the stray currents. And wherever possible, we should avoid the mechanical fasteners and we should prefer the welding, because when we have to join two metal parts, suppose these are the two metal parts which we are going to join. So we join them with the help of a mechanical fastener, that may be a nut or a bolt. So this is the nut or bolt. And here, these narrow spaces are poorly oxygenated. These are called crevices. So crevice corrosion may occur here. On the other hand, if those are joint, if these metal parts are joined with the help of welding, so this is the weld here. So in case of welding, there is no crevice formed, and because of the absence of crevice, the crevice corrosion will not occur here. So welding is preferred to the mechanical fasteners. So let us summarize it. This structure should be avoided, and this structure which does not allow the moisture retention should be preferred. Further, this structure should be avoided. It is not having the proper air circulation, whereas this structure should be preferred. The structure with sharp bends should be avoided. The structure with smooth bends should be preferred, and mechanical fasteners should be avoided. Welding should be preferred. Now we shall discuss about the second method, that is the modification of the corroding environment. The modification of the corroding environment can be done in two ways. The first one is removal of corrosion stimulants, and second is the addition of corrosion inhibitors. Corrosion stimulants are those species which cause the corrosion, which promote the corrosion. So removal of such species will prevent the corrosion. For example, oxygen. It promotes the corrosion because corrosion is the oxidation process. So it can be removed by deaeration or usage of reducing agent. Like we can use hydrogen here, or we can use sodium sulfite also. The second thing which promotes the corrosion process is acid. Acid lowers the pH and it stimulates the corrosion. So pH can be increased by adding lime. Adding lime. So it will increase the pH. The third thing which promotes the corrosion is presence of salts. These increase the conductivity and help in the corrosion process. So the salts can be removed by ion exchange reagents. Ion exchange reagents. The fourth thing which may cause corrosion, and it is mostly involved in the wet corrosion, that is moisture. Moisture can be removed by using silica gel. So these are the corrosion stimulants, and these can be removed to modify the corroding environment. Further, we can use certain corrosion inhibitors also. Corrosion inhibitors are those species which inhibit the corrosion process. Those may be organic or inorganic species as well. So these are called corrosion inhibitors. So let us first define them. These are the chemicals, those may be inorganic or organic, that inhibit or suppress the electrochemical process leading to corrosion by reacting with the metal or the surrounding gases when applied to the surface of the metal. So when we apply these materials, they inhibit or retard the electrochemical processes which are responsible to corrosion. These are called corrosion inhibitors. These are of three types, and the first type is called the anodic inhibitors. The name itself suggests that these are the inhibitors which react with the ions of anode to produce insoluble precipitates. So they react with the ions of anode and they form insoluble precipitates. These insoluble precipitates deposit on the surface of the anode and they work as the barrier or the protective film. That's how they inhibit the anodic reaction. Examples may include the molybdates, phosphates, and chromates. Here, one thing should be especially taken care of. That is their sufficient concentration. Because if we add less amount of the anodic inhibitors, in that case, the insoluble precipitate will be lesser in amount and it will not cover the anodic surface, the surface of the anode completely. It means some portion of the anode will still be remaining open. It will be still exposed to the corroding environment. In that case, the corrosion will be concentrated on very small area of the anode and it will expedite the corrosion process. It will accelerate the corrosion. That will lead to the pitting corrosion. So we should always take care of the sufficient concentration in case of anodic inhibitors. Sufficient concentration of anodic inhibitors should be ensured. Otherwise, it will accelerate the corrosion process. The second kind of corrosion inhibitors are cathodic inhibitors. These are the inhibitors which are adsorbed on the metal surface of the cathode, and they function as the protective layer. So they inhibit the cathodic reaction and they prevent corrosion. So these inhibit cathodic reaction, and this is how they prevent the corrosion process. Examples may include the amines, mercaptans, thiourea, and substituted ureas. Substituted ureas. These are the example of cathodic inhibitors. The third category of corrosion inhibitors are volatile inhibitors. Here also, the name itself suggests that these inhibitors have the tendency to sublime. They can easily sublime and form a protective layer on the surface of the metal. So they sublime. These are also called the vapor phase inhibitors. Examples may include DCHAN. DCHAN, this is dicyclohexyl ammonium nitrite. Dicyclohexyl ammonium nitrite. It is used for the protection of machineries and equipments when those are packed in containers and sent by ships. So this was about the corrosion inhibitors. Now we shall discuss about the third method, that is modification of properties of metal. The properties of the metal itself can also be changed. Those can be modified to prevent the corrosion process. It can also be done in three ways. The first is alloying. Alloying means to prepare the alloy. Alloy is the solid solution of two or more metals. For preparing the alloy, we add aluminium, chromium, titanium, or nickel metal to the steel or to the base metal, and these metals work as protective coating because they form the protective oxide layer. This is how they prevent corrosion. The second type or the second approach is refining. Refining itself suggests that it is the removal of impurities. Removal of impurities. And these impurities are mainly sulfur and phosphorus. So sulfur and phosphorus in the steel are removed, and this is how it prevents corrosion. The third approach is annealing. We have studied about stress corrosion, and during the discussion on stress corrosion, we discussed that For the stress corrosion to occur, we need mechanical stress, or we can say the residual stress in the metal object and corroding environment. So annealing is basically the heat treatment which removes the residual stress from the metal structure so that it does not undergo uh, corrosion in the corroding environment. So stress corrosion is prevented. The next kind of approach is the application of protective coatings. The protective coatings can be applied on the surface of the metal to prevent corrosion. These coatings may be of two types. The first one is called the organic coating, and the second category is called the metallic coating. Now we shall discuss them one by one. The organic coatings, application of the organic coatings is the traditional method in which paints, varnishes, enamels, and lacquers are applied to protect the metal surface. This is how they prevent corrosion by working as an inert organic barrier. The organic coatings here have two kinds of functions. First, they give a decorative look. So they impart a decorative look. And second, they prevent corrosion. To work as the organic coating, the coating should have certain properties, and among them, some of the major properties are it should have chemical inertness towards the corroding environment, chemical inertness. It should be tightly adhering to the metal surface, tightly adhering to the metal surface, and it should be impermeable to the gases, salts, and moisture. So this is how we can prevent the corrosion through application of organic coatings. Now, the second category is called the metallic coating. The surface coatings which are made up of metals are known as metallic coating. They separate the base metal from the corrosive environment, and they work as effective barrier for the protection of base metal. So we can use several kind of metals here like zinc, tin, nickel, chromium, copper, and aluminum also. So these metals can be used for the metallic coating. Now, the metallic coating itself has two types, the anodic coating and the cathodic coating. So we shall discuss them one by one. The anodic coating. In these coatings, base metal is coated with the more anodic metal, which protects the base metal. This is done sacrificially. So it is called sacrificial coating. Sacrificial coating. Why is it called sacrificial? Because this coating is more anodic as compared to the base metal. So corrosion occurs at the anode. It means this coating will undergo corrosion on the cost of protecting the base structure. That's why it is called sacrificial coating. Example here can be quoted as the galvanization. Galvanization. It means coating of zinc on the steel. In galvanized steel, the iron or the steel is the base metal and it is coated with zinc. Now, because zinc is more anodic, zinc will undergo corrosion and the underlying steel structure will remain protected. So we can understand it with the help of a diagram. Suppose this is the steel structure, and it is covered with the zinc coating. So here we have zinc coating. Now, because this structure, the steel structure is lesser anodic and zinc is having more anodic character. So zinc will work as anode and the steel will work as cathode. This structure having the zinc coating is in contact with the corroding environment. And here it is air. So because zinc is working as anode, it will undergo oxidation. So we can write it here as zinc converting to zinc ions and electrons are ejected. These electrons will move toward the cathode. So it shows the flow of electrons. So this is how the steel structure is protected because the steel is now working as cathode and corrosion does not happen on the cathode. It is occurring on the anode. Now, suppose this coating has a pore or a crack in it. So this is the crack in the anodic coating. In that case, the lower portion, the lower underlying steel structure is exposed. But because this is working as cathode, even after exposure to the corroding environment, this portion does not undergo corrosion. It will remain protected till there is any piece or any part of the zinc coating available on its surface. Now we shall discuss about the other type, that is cathodic coating. This may also be called as noble coating. In these coatings, the base metal is coated with the metal having noble character and higher corrosion resistance. So the coating metal has noble character and higher corrosion resistance. Higher corrosion resistance. Because the coating metal is having higher corrosion resistance and noble character, here it will work as cathode and the base structure is working as anode. Due to the higher corrosion resistance of the upper layer of the coating, the corrosion will not happen and it works as a barrier between the underlying steel structure and the corroding environment. So corrosion is prevented. However, this kind of protection is possible only when this coating is intact, when it is free from any pore or crack. So let us understand it with the help of this diagram. Suppose this is the underlying steel structure and it is covered with the coating, and this coating is cathodic coating this time. So this is the cathodic coating, which is having higher corrosion resistance. Higher corrosion resistance. Its example may be the tinning. It means tin coating on steel. coating of tin on steel. So we can write it here as tin coating. Now, because it is having higher corrosion resistance and it is having cathodic character as compared to steel, so steel will work as anode here. This anode is separated from the corroding environment due to the presence of this coating, which is working as barrier. Here it is here. So till the coating of cathodic metal is intact here, it is free from any pore or crack or any discontinuity. So till then, steel structure is protected from the corroding environment. But as soon as any crack or pore or discontinuity appears in the cathodic coating, this underlying layer is exposed to the corroding environment. Now, this area is working as anode. So it is working as anode, it means the corrosion will happen here. And because only very small portion of the anodic area is exposed to the corroding environment, it means the demand of the electrons has to be fulfilled only by this area. It means the corrosion here will be accelerated and it will lead to the pitting corrosion. The iron here will convert to Fe2 plus and electrons will be ejected and these electrons will move towards the cathode. So this kind of coating will work only till this coating is intact. It is free from any discontinuity or any kind of pore. Otherwise, it will lead to intense local corrosion or the pitting corrosion. Now let us compare the anodic coating with the cathodic coating. In the anodic coating, the base metal is protected by the sacrificial method. So it protects the base metal sacrificially. On the other hand, in the cathodic coating, protection is due to the higher corrosion resistance of the coating metal. So it protects the base metal due to higher corrosion resistance of the corroding metal. Sorry, higher corrosion resistance of the coating metal. Now, in case of anodic coating, if any kind of crack or pore appears, then even in the presence of crack or pore, the base metal remains protected. So we can write here base metal remains protected till any part of the coating is available. On the other hand, in case of cathodic coating, any break or pore in coating will cause accelerated rate of corrosion. In case of anodic coating, the reduction potential of the coated metal is lower than that of base metal because it is working as anode. So the reduction potential of the coated metal is lower. Because the coated metal is working as anode, so it should have low reduction potential. In case of cathodic coating, the reduction potential of the coated metal is higher than that of uh, the base metal. So we can write here reduction potential reduction potential of the coated metal is higher as compared to the base metal. As an example, we can quote here for anodic coating, we can quote the example as galvanization. Galvanization. That is the coating of zinc. Coating of zinc on steel. In case of cathodic coating, we can quote the example as tinning. That is the coating of tin on the steel. Now we shall discuss about the next method, that is the cathodic protection methods. The cathodic protection methods are also called electrochemical protection methods. So these are called as electrochemical protection methods. So these methods are based on the principle that when a metal undergoes corrosion, it is working as anode. And anode is responsible for oxidation process. And this oxidation process is the corrosion. It means if we prevent the role of metal as anode and we force it to work as cathode, in that case, the corrosion will not happen. This corrosion process will not happen if we force the metal to behave like cathode. So this is the principle of cathodic protection method. It can be done by two methods. The first is sacrificial anodic protection, and the second is impressed current cathodic protection. To see it clearly, we should erase it. So the first method is sacrificial anodic protection, and the second method is impressed current cathodic protection. Now we shall discuss them one by one. First, we shall discuss sacrificial anodic protection. If we connect a metal structure to a more anodic metal with the help of a wire, the corrosion will be concentrated on that metal which is more active or more anodic. This is the principle of the sacrificial anodic protection. Or we can say the more anodic metal will sacrifice itself to protect the base structure. Since the more anodic metal sacrifices itself to save the metal structure, this process is called sacrificial anodic protection. For this purpose, we generally use zinc, aluminum, or magnesium metals which have highly negative reduction potentials. We can choose these metals or alloys, and these are the most commonly used sacrificial anodes. So they have high, highly negative reduction potential. So those work as sacrificial anodes. And in this case, the corrosion process is mainly concentrated on these sacrificial anodes. Corrosion is concentrated only on sacrificial anodes. To understand it with the help of diagram, we can see here, this is the soil, and beneath the soil, in the soil, this metal structure is buried. So this is steel pipe. To prevent this steel pipe from corrosion, to protect it from the corrosion, we connect it with the help of a wire to a more anodic metal that may be either zinc or aluminum or magnesium. So this magnesium block is more anodic because this is more anodic, it will undergo oxidation and it will lose some electrons. These electrons will flow to the steel pipe, which is now working as cathode. And we know cathode is not responsible for the corrosion process, means the corrosion does not occur on the cathode. So this steel pipe will remain protected. It is working here as cathode. And this magnesium block was working as sacrificial anode. So this is how the steel pipe is protected from the corrosion due to the presence of more anodic metal or the sacrificial anode. It will remain protected till any part of this anodic metal is any part of this sacrificial anode is available. This method can be applicable its applications. This method is applicable in the protection of underground cables and wires, underground pipelines also. So protection of underground pipelines and underground cables. And it may also be used for the protection of ships and boats from marine pollution. To prevent the ships and boats from marine corrosion, a sheet of magnesium or any sacrificial anode is hung from the boat hull, and the body of the ship is protected, and the sheet of the sacrificial anode which is hung from the boat hull undergoes corrosion sacrificially. The next kind of method is impressed current cathodic protection. In this method, the corrosion current is nullified by applying the current from an external source in the opposite direction. So here we can summarize it as the corrosion current is nullified by applying the current from an external source in the opposite direction. Because the metal structure is now behaving as cathode, its corrosion will be prevented. The process here can be understood with the help of this diagram. Suppose this is our metal structure, which is made up of steel, and it is buried in the soil. So we connect it to the negative terminal of a DC power supply, and the positive terminal is connected with another, this positive terminal is connected to another electrode, which may be made up of either graphite or platinum. This anode is buried in gypsum, which increases its electrical contact with the surrounding soil. So this is connected to the positive terminal of the DC power supply, and negative terminal is connected to the base structure, that is steel. Now, because it is connected to the negative terminal, it works as cathode. And because this steel structure is working as cathode, it will not undergo corrosion. It remains protected. This method is applicable This method may be applicable for the protection of pipelines, protection of pipeline, transmission lines, tanks, which are buried in the soil, and other buried structures. So we have seen that both of the cathodic protection methods are based on this principle that the base metal should work as cathode. In the sacrificial anodic protection method, we added a more anodic metal to the base structure, whereas in impressed current cathodic protection, we connected it to the negative terminal of the direct current power supply so that it works as cathode. And in both cases, the base structure is protected because it is working as cathode. Now, we shall discuss a few questions which have appeared in previous years' examinations. The first one is, how can corrosion be minimized by proper design? This question we have discussed, this part we have discussed. Here. So material selection and design can be used to prevent the corrosion. These are the ways to prevent the galvanic corrosion, and these are the methods to design the structure which will be protected from the corrosion. The next question is, discuss the mechanism of electrochemical theory of corrosion by absorption of oxygen. What effect will increased oxygen supply have on such corrosion? This part we have discussed in previous sessions. The remaining part, how can corrosion be minimized by proper design? That will be answered in the same way as we have answered the first question. What are corrosion inhibitors? Explain with examples how anodic and cathodic inhibitors provide protection against corrosion. So, those species which are added to the corroding medium to prevent corrosion are called as corrosion inhibitors. We have discussed uh, their types. Those are of three types: the anodic inhibitor, cathodic inhibitor, and vapor phase inhibitors. Now we shall discuss about the examples and how do they work against corrosion. The same question has been asked in another way. Outline the mechanism involved in electrochemical theory of corrosion. This mechanism has been covered in previous sessions. How corrosion is prevented by anodic and cathodic inhibitors. So both of these questions will be answered in the way as we have discussed previously. So here we have discussed. These are the corrosion inhibitors. These are the chemicals that inhibit or suppress the electrochemical processes leading to corrosion by reacting with the metal or the surrounding gases when applied to the surface of the metal. These are of three types: anodic inhibitor, cathodic inhibitor, and volatile inhibitors. So these we have discussed here. The next question is briefly explain wet corrosion. This part we have discussed in previous sessions when we have discussed the mechanism, how corrosion can be prevented by metallic coating and using corrosion inhibitors. So corrosion inhibitors we have just discussed in the previous questions, we have answered it. Regarding metallic coating, this we can write. Surface coatings made up of metals are known as metallic coatings. They separate the base metal from the corrosive environment and also function as an effective barrier for the protection of base metal. It has two types, anodic coating and cathodic coating. The anodic coating has been discussed here, and the cathodic coating has also been discussed here. We can compare anodic and cathodic coating with the help of this table. Then the next question is, why is a block of magnesium attached through an insulated metallic wire to an underground pipeline? This is an example of sacrificial anodic protection. So we will explain the sacrificial anodic protection here. The next question is, discuss the electrochemical theory of corrosion along with equations. This part has been discussed in previous sessions during the discussion on mechanism of corrosion. Explain why sheets of zinc metal are hung around the hull of ocean-going ship. This is also explained on the basis of sacrificial anodic protection. So first we will answer the first question here, and then we will explain why zinc metal is hung around the hull of ocean-going ships. Among the cathodic protection methods, the first method is sacrificial anodic protection, and here we have discussed sacrificial anodic protection where the base structure of the metal is connected to more anodic metal, and the more anodic metal sacrifices itself to protect the base structure from corrosion. Now, explain why sheets of zinc metal are hung around the hull of ocean-going ship. Suppose this is the hull of the ocean-going ship. It is in the ocean and it is having a block of zinc metal hung around its hull. So this is more anodic metal. This boat is made up of steel. And this more anodic metal is basically the zinc metal, which is zinc sheet is hung around its hull. So because it is more anodic, it will work as sacrificial anode. Sacrificial anode. So it will undergo corrosion on the cost of the protection of the body of the boat, which is made up of steel. So it undergoes corrosion. Till any part of the sacrificial anode, that is the zinc metal, is hung here, the steel will work as cathode and it will remain protected from the marine corrosion. This is why the zinc metals are hung around the hull of ocean-going ship. The next question is, comment on the use of aluminium in place of zinc for cathodic protection of iron from rusting. We know in case of cathodic protection, the metal which is prone to corrosion is forced to work as cathode. It is done by placing a more anodic metal which works as anode and the base structure works as cathode. So we can use the zinc here and we can also use aluminium here. But it means zinc and aluminium both can be used for sacrificial anodic protection. We know that aluminium is a metal which can also form a protective oxide layer once it starts corroding. So that oxide layer works as protective coating. Further, the aluminium has more negative reduction potential as compared to zinc. More negative reduction potential as compared to the zinc ion. So aluminium will be better used for the protection of the iron from rusting as compared to the zinc. Describe electrochemical theory of corrosion. How corrosion can be prevented by sacrificial anodic protection and impressed current cathodic protection. So sacrificial anodic protection and impressed current cathodic protection will be explained here as answer. The first part of this question, the electrochemical theory of corrosion, has been discussed in previous session where we discussed the mechanism of corrosion. The same question is asked in a different language. Define the term corrosion. Here we have to define corrosion. Describe the mechanism of electrochemical corrosion with the help of hydrogen evolution and oxygen absorption reactions. This is the question again from the mechanism of corrosion, which has been discussed in previous sessions. How it can be prevented using sacrificial anodic protection. So the last part of both questions can be explained. This is the sacrificial anodic protection where the base structure is connected to more anodic sacrificial anode. The sacrificial anode undergoes corrosion and the base structure, which is working as cathode now, remains protected. Similarly, in impressed current cathodic protection, the metal object, the base structure is forced to work as cathode because it is connected to the negative terminal of the direct current power supply. The positive terminal is connected to a graphite or platinum electrode, which is surrounded by the gypsum backfill to increase its conductivity. So this is how sacrificial anodic protection and impressed current cathodic protection helps to prevent the corrosion of base structure. Describe the mechanism of electrochemical or wet corrosion with the help of reactions. This part has been discussed in previous sessions where we discussed the mechanism of corrosion. Explain the cathodic protection method of prevention of corrosion. So this has already been explained in previous questions. Explain the mechanism of hydrogen evolution and oxygen absorption with the help of electrochemical theory of corrosion. This is again the same question regarding the mechanism of corrosion, which is discussed in previous sessions. Explain noble and sacrificial metallic coatings for preventing corrosion. So we are we have to answer here by explaining metallic coatings. These are the metallic coatings. So these are of two types, anodic and cathodic coating. Anodic coating, uh, that coating where the metal behaves as a sacrificial coating and the base structure remains protected. And cathodic coating, where the coating is corrosion resistant, it works as a barrier between the underlying base structure and the corroding environment. This is the comparison between anodic and cathodic coating. The next question, explain the mechanism of hydrogen evolution and okay, this question we have explained. The noble and sacrificial metallic coating. We have to remember that noble coating is also called cathodic coating and sacrificial metallic coating is also called anodic coating. So we can understand that this topic is very much important and it has been asked again and again using different sentences by reframing the sentences. These are the references and thank you for attending this session.